Okay, this is the Algebra 2, lesson 2.6, families of functions. In this video lesson, we're going to analyze transformations of functions. So here's an example of a graph, this red graph here, f of x. If you add a number, say k, to the function, it just moves the graph up. If you subtract a number from the function, then it just moves the graph down. And that's called a vertical translation. A horizontal translation is going to be adding or subtracting a number from the x before you put it into the function. And what that does is, I know you think adding something would move it to the right, but in fact, adding a number moves it to the left because it's the number you're subtracting, or the number that you can plug in here to make 0. And so if you see that a number was added to the x before it goes into the function, it moves left that many, and if a number is subtracted from the x before it goes into the function, it shifts it to the right. That's called a horizontal translation. Okay, so let's look and see how the functions y equals x and x minus 2 are related, and then how are their graphs related. So you can see here that this is my, if this is my f of x, right, if f of x is x, then y is f of x minus 2. So we have now subtracted a number from the f of x. And so that's going to be a shift down. So this is a shift down by 2. And that is how their graphs are related. I guess this first question is, right, you subtract 2 from the function, that's how they're related, and then their graph shifts down by 2. Okay, so try this next one on your own. What is the graph? Oh no, this one's not on your own, sorry. This one's for me too. Okay, this is f of x equals x squared. It's translated up 4 units. So up 4 units is going to be a number, well, 4. K is 4, and we're going to add it to our function. So our new graph, let's just call it g of x, is going to be f of x, which is x squared, plus 4. And we can actually graph that. You can graph the original, which is at x squared is just at 0, 0, 1, 1, and then 2, 4. And then you can reflect it. So this is the original one. That's my f of x, or my x squared. And if you go up 4, just move each of these points up 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then you can reflect it. And then this is going to be my g of x, right? This is just my x squared plus 4. Okay, so here's one for you to try on your own, or maybe there's another one on the next page. But try this one first. Press pause and then check back for the solution. Just write how are they related, and then how are their graphs related? What happens to the graph? So press pause and then check back. Okay, so you see here, my f of x is x squared, 2x, and here's my 2x, which is my f of x, and it's just minus 3 after that. That means the graph shifts down 3, right, because you're subtracting a number, right? It's this one here. Right, it's we have our function and we're subtracting 3 at the end there. Okay, is there another one for you to try? Yes, there is. There's one for you to graph. So what's the graph of 3x translated up 2 units? So graph your 3x and then move it up 2 units and draw that graph as well. So press pause and try that on your own, and then check back for your solution. Okay, and then here's my, if y equals 3x, right, what's that graph translated up 2 units? So that means f of x is 3x. And if it's going up 2 units, you're just adding 2 to that function, which is 3x plus 2. And then you can graph 3x, which is just my y-intercept is 0. My slope is 3, so up 3 over 1. Up 3 over 1, you can do that backwards, draw your graph. And then at each point, just move up. Oh, I did 3 units. Sorry, this is wrong. It should just be 2. I did 3 because I was doing it too fast. So 1, 2, so it should be here. There you go. Ignore that blue one. Let's write this in red so you know. I wrote the function right, but I moved it up 3 instead of 2. Anyway, hopefully you get the picture. Okay, moving on. Problem 2. So this graph shows the projected altitude of an airplane scheduled to depart an airport at noon. If the plane leaves 2 hours late, what function represents this transformation? So let's see, here's our graph, right? This is if it was on time. But it was 2 hours late, so it's still going to follow the same path, but just it moved to the right too. Right, so this has moved to the right too. So remember, when we move horizontally, if you're moving to the right too, that means you're going to subtract 2 from x before you put in the function. Which is represented as f of x minus 2. Okay, so that's how we would do that one, but it's asking if the plane leaves 2 hours late, what function represents this transformation? Oh, here, just f of f minus x2, that's what I did. Yeah, that's the answer. So you subtract 2 from the x before it goes in. Right, before f of x, if you're going to go down, you do it after. This is after. And if you do it within inside the function, right, this is before. So this is left to right, this is up or down. Okay, suppose the flight leaves 30 minutes early. What function represents this transformation? Okay, so 30 minutes early, and remember that we're in hours. So press pause, try this one on your own, and then check back for the solution. Okay, and then since we're earlier, right, later is going right, earlier is left. So we're going to move left, and since 30 minutes is half of an hour, we're going to use half, which is 0.5. And so since we're moving left instead of right, we're going to add 0.5 before. So, and before means it's inside the function, like to the x before, so it's going to be f of x plus 0.5. Okay, so those were translations that go to the right or to the left or up or down. So the next ones we're going to talk about are reflections. So a reflection is something that flips the graph across a line, such as the x or y axis. So here's my y axis. If this is my function, and we reflected it across the y axis, it would just imagine that it just flips across this line and there. It's kind of like if you looked in the mirror and the mirror was here. That's what would show up. And then if you reflect in the x-axis, it's if the mirror was here, and it would flip this way. Okay, and so when you reflect in the y-axis, the way that your function changes is that the x gets a negative, you get multiplied by a negative number, or the sign changes on your x before it goes in the function. If you reflect in the x-axis, the sign changes after the x goes in the function. Okay, so so reflect in the y-axis, negative f of negative x, reflect in the x-axis, negative f of x. So let's see how that works in an example. Let g of x be the reflection of f of x, which in this case is 3x plus 2 in the y-axis. What is the function rule for g of x? Well, remember that if it's in the y-axis, then my function gets the negative number, the x gets the negative inside the function. So in this case, we would, this x would become negative before it went in. And so this would become negative 3x plus 2. That would be my g of x. Okay. And then, so this is the same thing, but this time it's reflected in the x-axis. So see if you can figure out how it's different or how it changes if we're reflecting the same function f of x in the x-axis. What is the function rule? So press pause and try this one on your own, and then let's check back when you're done. Okay, so only a small change, but remember this: if it's reflecting the x-axis, the negative goes after after you have the function. So your x goes in the function regular, it gets multiplied by 3, it gets added to 2, then it gets multiplied by negative 1. So both of these get the negative 1. So when you distribute the negative, you get negative x minus 2. So see how it's different? Same slope, but different y-intercept. Okay, so another kind of transformation would be a stretch or a compression. It's best seen on these kind of curvy functions, but a vertical stretch just multiplies all the y values of the function by the same number that's greater than 1. It's a stretch, so you can see if this blue is my normal function, the red gets stretched, and that would just be a by a number a if that number is greater than 1. Okay, if it gets multiplied by a number that's less than, well, actually in this case, a is going to be between 0 and 1. So if, this number 1 over a would be between, oh, sorry, a is greater than 1. And so if a is greater than 1, then 1 divided by a would be between 0 and 1. And so that function gets smaller, kind of shrinks or compresses. Imagine it being pushed down on, right? And if it's bigger than 1, it's being pulled on. So basically, your function or stretch and a compression has the same. It's basically y equals a. So some number a is being multiplied by f of x. It's called a stretch if a is greater than 1. It's called a compression if a is between 0 and 1. And remember, you don't care about the sign. It's always going to be the absolute value. It's always going to be the positive version of that number, because if it was a negative number, the negative represents the reflection. So if you had a negative number, right, the negative would represent the reflection, and then the number, magnitude of the number, would reflect if it was a stretch or a compression. So let's see how this works in an example. This table represents a function. What are the corresponding values of g of x and possible graphs for the function transformation if it was 3 of f of x? So you can see this in a table pretty easily, right? If you multiplied, so this is the 3 after the f of x. So your y values get multiplied by 3. So 2 times 3, right? If you multiply these all by 3, you get 6, 6, negative 9, 3, and negative 6. And so if you wanted to graph this, I think they ask for the possible graphs. Here, I'll do it on pause. Okay, so this is a possible graph. Sorry, it's the reason it says possible graph is all we know is these points. But I'm going to just make a graph that just has lines connecting the points. So let's say this is our graph. And now, if we graphed the 3f of x, right, then this becomes negative 5. This goes up to 6. This also goes up to 6. But then this next one, 0, goes down to negative 9. 6, 7, 8, 9, probably something down here. And then this one goes up to 3, and then this one goes down to negative 6. Okay, and so if we assumed the lines again, you can see what happens, right? You can just see how this just gets pulled up and down, just gets stretched by this 3. And that's because 3 is greater than 1, so it's a stretch. Okay. Here's one for you to try on your own. So you're going to do the same exact one as before, but you're going to do 1/3 of f of x. So let me get that table here. Okay, so here's your table. It was on the other page, so I rewrote it here so you can see it. So press pause now, fill this out, 1/3 f of x, redraw your graph, assuming lines in between, and then make your new graph here, and then check back for the solution. Okay, here you go. And then you can see here, right, this one actually, the red one gets smaller, it gets compressed in towards the x-axis. So this is a compression by factor, and you just always say the factor. Compression by factor 1/3. Okay, and here's a little summary of what we've just learned. These are all the different transformations, and this is a good table to have while you're doing your homework. This shows the vertical. It's you add, if it goes up, you add a number to f of x after the x goes in. If it goes down, you subtract it after. Horizontal is if it's right, you subtract h units from the x before it goes in the function. If it goes left, you add h before it goes into the function. Vertical stretch is just a number times f of x, if that number is greater than 1. And then compression, also just a number times f of x, but it's a compression if that number happens to be between 0 and 1. And then the negative on the outside of the function means it reflects in the x-axis, and the negative inside before you do the function, so just on the x, is a reflection in the y-axis. So let's just do a couple more examples, and this one's going to combine transformations. So if the graph of g of x is, f of x is 4x, it's compressed vertically by a factor of 1/2 and then reflected in the y-axis. What's that function rule? Okay, so let's just take these by steps. Compressed vertically by a factor of 1/2. That means this is going to be 1/2 of f of x. And in this case, our f of x is 4x, so this is going to be 1/2 times 4x. So our new function is now 2x. Okay, and then it says reflected in the y-axis. Well, remember, reflected in the y-axis is when you get the negative on the x before you plug it in. So this would be 2 times negative x, which just becomes negative 2x. And so that's my g of x, negative 2x. Okay? And then this next one says, what transformations changed the graph of f of x to the graph of g of x? And this one's difficult because I actually did not include what f of x and g of x were for this example. So f of x happens to be 2x squared, and write this in your notes because these are not included in your notes. The notes you have doesn't have this. And g of x is 6x squared minus 1. Okay, so write that in your notes. Okay, so what we see here is this is my f of x. And so to get to g of x, first this 2 becomes a 6. And so how do we get that? We have to multiply that. So if this is my f of x, let's multiply this by 3. So then this step becomes f of x, or let's just do 3 times f of x, right? Which is 3 times 2x squared. That becomes 6x squared. When we multiply a function by a number, remember that's and the number that's greater than 1, this is going to be a vertical stretch by factor 3. So that's my first transformation, right? So actually, what transformations? Okay, so now we're at 6x squared, but we also need this minus 1. So if this is my function, right, and I'm subtracting a number after that, that means it's going down by 1. So that's my second transformation. So this function was vertically stretched by 3 to get to the 6x squared, and then it went down by 1 to get this minus 1. So these are my two transformations. This is the answer. Vertical stretch by factor of 3 and then down by 1. Okay, so one for you to try on your own here. The graph, let me make sure I included everything you needed to. The graph of g of x is the graph of f of x equals x. Stretched vertically by a factor of 2 and then translated down 3 units. What's the function rule? So just do one like this. Press pause, try this on your own, and then check back for the solution, and then we'll be done. Okay, and then hopefully you got 2x minus 3. This is my f of x. To be stretched vertically by a factor of 2 means just this x gets multiplied by 2. And then when you translate it down 3 units, you subtract 3 after the function, so not inside. And that's it. Okay, time for practice. Enjoy.